Okay, so we are on page 13, and you guys already told me this. The top of page 13, probably the number one thing that all of you got before we even cleared it up, is your latitude, which means how far north or the south of the equator you are, controls your latitude. So, no, controls your climate, sorry. So right there, and I see that it looks like the latitude word was removed with the hole punch. So if you can't see that says latitude, right underneath that says latitude. And this is the first thing we need to talk about with latitude. Yes, this part's review. You need to know that the word latitude talks about how far north or south of the equator you are. Are you lost, Carter?
No.
You wrote this?
Yes.
Okay.
Oh,
Oh, that's weird, actually. Do your head, everybody else have holes?
yeah.
No.
Fire.
That's really weird that yours doesn't have holes.
Maybe not.
But anyway, not important for the event. Not,
It could have had holes like this.
oh, okay. Not important to the lesson whether it has holes or not, but latitude. Guys, don't get latitude and longitude confused. Latitude is how far north or south of the equator you are. Hey, I didn't mention longitude up there. Does longitude control your climate? No, it doesn't matter if we're here or over by my brother in Oregon. It's not his, he's actually at the exact same latitude we are. He's just at a different longitude. So latitude is the one that controls your climate. What's the latitude of the equator?
Yeah.
What's the latitude of the North and South Pole? Okay, that is something that you pretty much need to know off the top of your head as well. If you don't, I did include this second and third bullet. The higher the latitude, which I did tell you are the poles, the latitude is colder. If you know that without thinking, yeah, guess you don't need the bullet, but most of you did not automatically say off the top of your heads that 90 is the poles. Because that's where people get tricked up. Higher latitude is the poles, lower latitude in the middle, the equator. But really all this is saying is closer to the poles, colder, closer to the equator, warmer. It's this last bullet that I feel is most important that you write, because this is the one you don't think about, and we're going to talk about it in just a second.
Good.
All right. Let's talk about this last one. Did everybody write the last bullet already?
Yes.
What do I mean? As you travel away from the equator, the temperature range increases. What's temperature range? Let's start there.
How far temperature?
Okay, good. So the the coldest temperature is 50, the hottest temperature is 100, the range is 50 to 100. Perfect. So let's talk about what's our temperature range in the Buffalo area.
Like 0 to 50.
Okay, yeah, so it does get as cold as 0 Fahrenheit, that's a really cold winter day though. So on average, I'd say, what do you think our average winterish temperature is? Not normally 0 Fahrenheit.
30. 30 is 60.
Yeah, I think that's one. I agree with you, that definitely gets as cold as 0. 30s are completely normal as well. So I'd say in the winter, we are, let's say 25. To what are we in the summer? What's a normal summer day? Yes, we can
75, like 70.
70, I wish. I think, is it summer in the 70 in the summer? You think that's like our normal everyday summer? No, it definitely is around there. Just like we do get up to 90, but would you say that's a regular? So I think something in the 80s maybe.
Okay,
So our range, just to make my math a little bit easier, I'll say 20 to 80. We have a 60-degree temperature range-ish here in Buffalo. So that's why we gotta tell our exchange students they need really cold clothes
average.
and really warm clothes. They need everything. So then let's talk about the temperature range at the equator. I did not officially look this up yet, but what do you think the coldest it gets? I'm gonna Google it, sorry. I already Googled Alaska, I didn't think to Google the equator yet.
I would say like 90. Yeah.
So it says most equatorial countries, whatever the time of the year, you can expect the temperatures to range from 70 to 8, from the high 70s to the low 90s. And it said that was all year long. It doesn't matter what month. Why does it not matter what month at the equator? Right, the equator is warm all year long. They don't have seasons. So at the equator, there's not much of a temperature range. What about Alaska? What do you think? How cold is their winter?
Negatives.
It's definitely the negative. I know you guys never watched Intro Truckers. No, okay, I know you. So what about that family that lives in Alaska? Yeah, that family that lives in Alaska, what's that show called? There's one that's in Alaska, the Final Frontier or something like that. I just looked it up, I just Googled it, I don't know, remember where I wrote it. It said, normal temperatures in Alaska winter cover between -35 and 0 degrees Fahrenheit. So just to make my math easier, if it goes negative 30. And you know how hot it gets there? Oh, in the summer. It is not uncommon, they said the average temperature is between 60 and 70, but they have had highs as high as 90 degrees in Alaska. Yeah, that's a real hot day in Alaska, but so we'll say, it did say 60s to 70s. -30 to 70 degrees. What kind of range are we talking about there?
100.
That's a 100-degree temperature range. That's a really big range. So this is a big range here, a really small range here. And in Buffalo, which is about in the middle, we have a medium range. So here's what that means. As we get away from the equator, the temperature range increases, meaning the high and the low are really far apart as the further you get from the equator. That's what that one meant. Then the next thing, latitude is one major factor that controls the climate of an area. Then the next one you guys mentioned was elevation, which is how high you are, like at the tops of the mountains. And again, like Kat said, tops of mountains have snow on them, even in the summer. So that means the higher the elevation, the colder the temperatures stay. Right there. An elevation now. Or did I call it altitude? It's elevation, good, because that's the right way to say it. You can put yes. So I again don't think this one is news to you. You knew this. But there's going to be a second bullet again that you've never thought about. Let's talk about the temperature range on the top of a mountain. Is there a big temperature range or a little temperature range on the top of a mountain? Why little? How can you kind of justify saying little? Because there's literally snow in the summer. So in other words, it's cold or pretty darn cold all year long. So the higher the elevation, the smaller the temperature range. Meaning they're just cold all year long at the top of a mountain.
Why is it snowing?
Well, it's not there yet, dude. We're getting hit with a cold air mass right now. Little cold, little wet. It was just snowing.
Okay. It should be snowing, it's kind of snowing, might as well make it snowing for the kids.
The next one is nearness to a body of water. So we talked about this one already. We are near a body of water. Now Pioneer's not like right on top of Lake Erie. But if we talk about the city of Buffalo, which hopefully you guys have visited a few times.
More than.
Okay, or if you even, did I just hear that baseball was at Lake Shore yesterday?
Good job, Ken.
Okay,
She was.
is that you?
No.
Oh, no baseball for you.
She's good.
Oh, okay. So then I can't use that as an example, but hopefully you've been to Buffalo a few times. Let's talk about, what does the lake do to Buffalo in the summer? Does it? In the summer. Let's say it, so does it make it colder or warmer, you think, in the summer?
Older.
Yes, it all does depend on the temperatures of the land and the lake. Let's say it was 85 here in Pioneer. Nice 85-degree day. What are some activities you want to do on an 85-degree day? Okay. Swimming. Let's go to the beach. Let's go to the beach on that 85-degree day. So we go to Sunset Bay, you go to Evangola, you go to Hamburg, Town Park Beach, whatever it's called. You're going to the beach. You're over there. How's the temperature feel? If it was 85 here, it's colder. Why is it colder, by the way? Because the lake's colder. So yes, the wind has to do with it, but the key is that the lake is colder.
Right now it's 42 degrees like Erie and Buffalo Harbor.
Ooh, 24 degrees. Let's talk about that one in a second. So we want to talk about the 85-degree day. So actually, we can talk about it. It was 85 just a couple days ago, wasn't it? Or darn near close to it. I also wish it still was. But when we went over to the lake, I actually did go over to the lake. I went to have dinner right on the lake the other day.
You're right on water.
I was right next to the water. Okay, so I'm thinking we can't handle this good boys and girls stuff. So we went over to have dinner. We froze our tuchuses off. My what? We froze our butts off. Why did we freeze our butts off when it was 85 degrees at my house? Because you were next to the cold lake, and how what's the temperature of the lake? The heat is like today. So there's water and the wind coming at me from the lake was 44 degrees. It was still cold as heck next to the lake. So when the lake is cold and the land is hot, we're gonna feel that colder breeze. But let's talk about in the winter. What temperature does the water freeze at? 32. So let's say it was 25 here at Pioneer. You go over to the lake is not frozen. How do we feel in the middle of the winter then? If the lake's not frozen, slightly warmer. Because yes, even if the lake is at 32 or 33, which sounds cold as heck, it's warmer than 20 something.
November 1st of this year, it was 57 degrees.
Okay, so in November, it wasn't 57 degrees here in November, but if you go over to that same restaurant that I was just at, and if it was 30 something in the air, but the lake is 50 something,
What is the water?
you're hot. Because it takes water a long time to heat up, a long time. This year, the lake never froze. It never got below 32 this
Tell
year.
me that the waters can be as warm as the sunny day.
It depends, yeah, so it was 57. In November, the lake was warmer than the air right now.
That's crazy.
Yep. So let's get this last set of notes in, and then we still need to go over your homework from yesterday. Here is the last notes we're doing for today on still on page 13, right? Nearness to a large body of water causes a smaller temperature range. We just talked about how the lake keeps us slightly warmer in the winter. And then again, slightly cooler in the summer. The lake cools us off in the summer, keeps us a little warmer in the winter. And just like Jeff said, this is because it takes the water longer to heat up and longer to cool down. And then when you're done, I do want you to go back to your seat and turn to page 6 for your homework. So again, when you're done writing, head back to your seats and turn to page 6. Nope, you're going back to your seat. We only have a few minutes and I do need to get through the homework. If you haven't noticed, we are farther than halfway through the packet already. This is a very short packet. Expect the test either at the end of this week or the beginning of next week. All right, so we're on page 6. Right off the bat, I can tell from question 6 that we need to make sure we remember a couple of vocab words. Guys, what is permeability?
Ability to go through.
Okay, so that's the ability to soak in or go through. What is porosity? Whole space. What is capillarity? Which way is the water moving? Up. Upward movement. And what about runoff? What's happening if there's runoff? It is going from one area to another area. The water's going downhill. What's not happening with the water if there's runoff? It's not soaking in. Yep. So I know just from this question that you need to know those 4 words. Permeability is soaking in. Porosity is the whole space. Capillarity is the upward movement of water, and runoff happens when water does not soak in. You did have to look at this and you saw that it rained. They're telling you that this is 10 minutes after the rain, the soil looks like this. You can see that A is still filled up, B has drained, and there's only a little bit. So what must be true? That A is still filled up and B is drained? No. Which one will, so what's happened? Where'd the water go? It went in the ground. It soaked in. So why does A not soak in 10 minutes, but B does? Has a higher permeability. The ability to soak in is greater in B than it is in A. What's wrong with answer 2? What did we say about the porosity of each one? Porosity is the whole space. But remember, they both have the same amount of hole space. Okay, there's a lot of little holes here and a few really big holes here. In the end, they have the same pore space. How about this one? During rainfall, surface runoff will be greatest when So again, if we have runoff, what's not happening? What's not happening if we have surface runoff?
Infiltration.
Okay, so it's not soaking in. I want you to literally stop and think, what the heck does it mean? We want which one will have the most runoff, which means which one is it not soaking in? Looking at the slope, steep slope or a gentle slope or not, right? Why does it not soak in on a steep slope?
It's running off.
So versus these two slopes,
Bigger angle of the stuff.
right? So what's gonna happen if it rains on this steep slope?
It's gonna go down.
Yeah, gravity's just gonna take it down the hill, so it won't have a moment to stop and soak in. The more that gentle the slope is, it's going to sit there and have a chance to soak in. Then we want, which one will be better, clay or gravel? What the heck? What? I don't know anything about clay off the top of my head.
Like build that.
That's not it.
Look at the reference table.
So, yes, you're supposed to look stuff up.
Uh,
When we're talking about clay, I don't want you just to think about what you normally thought about clay, that giant hunk of wet yuckiness.
oh,
I want you to think of clay as being the smallest size particle. Gravel, now that's not on here, but you should know that gravel is like pebbles and cobbles maybe mixed together. It's bigger size sediment. So which one will we have the most runoff? Yep, number one, because clay is the smallest. This one, yes, it was important to read this and look at the pictures. What they told you is that it's soaking in cups of water. Which column has an average diameter closest to 0.1 centimeters? Yeah, you gotta look that up again. See how the Regents combines two chapters that we've done? They love that kind of stuff. 0.1 centimeters right there, which is firmly in the sand category. Would you call this line large sand or medium sand? That's really close to the top. I would call that large sand, which is answer B. Now we want to know which one's going to have the most capillarity action. And from the notes yesterday and on Friday, capillarity action happens the most with which size sediments? Big or small? Capillarity action. Small, right, remember. We want the smallest. Guys, which one's the smallest out of these choices? No, no.
Large.
Here's pebbles.
Ah,
Here's sand. Here's silt. That's large silt. See how they tried to mess with you?
Yeah, because it said large.
Because it said large. They did that on purpose.
It means
And notice how they put the small word first.
that's fine.
Okay, almost, I'm happy if you picked small pebbles because you saw the word small and you're like, okay, I know it's the smallest. So you at least understand the concept that capillarity action happens with the smallest. But you fell for their trick. Out of these four, large silt is the smallest. Use your reference table. All right, now they're changing the experiment. They take all the water away. They dump new water in. Which one, the permeability rate of the medium sand, will it be less than silt or greater than silt? Permeability of medium sand, so sand compared to silt,
Greater.
it will be greater, meaning it'll go through faster. But will it be less than pebbles or greater than pebbles? Less than pebbles because sand is smaller than pebbles. Which graph represents runoff and soil permeability? When we're here, what does that mean for soil permeability when we're close to the origin? Does it mean it's going in fast or slow? This side is slow. This side is fast. So if it's going slow, do we have a lot of runoff or a little bit of runoff? If it's soaking in slow, That's gonna be a lot of runoff. If we have soaking in fast, will we have a lot of runoff or a little bit? Little bit, this is the answer. When rainfall occurs, the rainwater will mostly likely run off if the land surface is impermeable. That means can't soak in. If it can't soak in, it absolutely will run off. Let me, oh shoot, we'll continue on here, but I can give you the answers real quick. We've got number 1 for 8. We got number 3 for number 9. Most infiltration would be gentle and permeable, answer 2. Yeah, oh yeah, you got homework tonight. It's 9, 10, and 11. Sorry about that. Just 10 and 11. Don't forget it. 10 and 11. Don't forget to do your homework, pages 10 and 11.